Hi, everybody. Welcome to Lesson 1, Introduction to Statistics. So, here we go. Next slide. Our agenda today is first, we're going to talk about a few definitions, and then we'll talk about how social science research has changed over time. We'll talk briefly about why we need statistics before talking about descriptive and inferential statistics. And finally, populations and samples. Slide 3. So first, some definitions. For statistics, we're going to think about statistics as being a set of procedures and rules for reducing large masses of data into manageable proportions and for allowing us to draw conclusions from that data. But there's another definition another way it's used. There's the idea of a statistic, that is what you get when you apply those procedures or rules. So it's the result of some kind of manipulation of data. For example, when you compute an average, the average is a statistic. You used statistics to compute a statistic. Next slide. So how has social science research changed? And I'm including education research in social science research, as well as psychology, sociology, and other aspects of the so-called soft sciences. Way back in the old days, the obsession was with how precisely can I measure something? And if I do this study again, will I get similar results? Basically, social scientists, especially psychologists, were obsessed with trying to be like physics and chemistry. And this idea of precision and replicability was very important. Now, more recently, the question has come, are the differences I'm finding meaningful? And so social scientists started paying more attention to the size of the effects that they were finding, not just whether they were one thing was statistically different from another, but whether that difference actually had meaning in the real world. And this is something that education and other professions really are strong in terms of being focused on the meaning behind the numbers, not just the numbers themselves. And now there is increasingly a focus on how does a particular study or line of research contribute to knowledge in my field? Will it provide the evidence that's needed for practice? Are my interventions actionable in real contexts? And so these are some of the questions that are being asked about social science research now, and that has certain implications for statistics. So why do we need statistics? This is slide 5. First of all, like I said, it allows us to see patterns in big data that we wouldn't see otherwise. So for example, if you're looking at test scores from every student in your school, you might have 100, 200, 300, 1,000 test scores depending on the size of your school. And it's very hard to see patterns. But statistics allows us to summarize those numbers in a way that we can start to see patterns. Also, it provides information that was determined by agreed upon methods. So the information is seen as legitimate. Now, whether it should always be seen as legitimate or not is something for another day. But statistics often, because the procedures are agreed upon and the methods are standardized, statistics are seen as legitimate. And finally, statistics can be used to evaluate current interventions and provide support for proposed interventions. So if you are looking for to see if a program that you've implemented at your school is working, statistics can help you to make that determination. If you're applying for funding for a new initiative that you want to get started in your school or school district, statistics can help you provide support for your proposal. Next slide, slide 6. So why do you need a Foundations of Statistics course? Our first goal in this course is to gain a statistical vocabulary and mindset. So a way of looking at numbers and critically evaluating what those numbers mean. So first, vocabulary and mindset. Second, I want you to be able to answer research questions related to your profession and to be able to understand the answers that others are giving to various research questions in your field. And it helps having a statistical vocabulary in order to be able to understand quantitative research. Third goal, to have a strong foundation for learning intermediate statistics and doing a research study. So some of you are currently in a doctoral program. Some of you may want to be in a doctoral program in the future. The level of research you're going to want to do if you choose to do quantitative research is going to require intermediate or advanced statistics, and this class will provide a foundation for that. And finally, to fulfill the requirements of your degree program. Yes, many degree programs nowadays are requiring foundational statistics. And the reason is they want to be able to say, hey, our graduates are literate in this way of thinking about numbers, in this way of looking at the world. And so that may be why you are in this class. Next slide, slide 7. Okay, let's talk about populations and samples. Now, normally when we're thinking about a population, we're thinking about a group of people. So we might say the population of South Dakota. In statistical terms, when we're talking about a population, we're talking about all the people, objects, or events that we are interested in. So for example, let's say we were doing a study on how old graduate students are at the University of South Dakota. So for the population there are the ages of all graduate students at the University of South Dakota. Now, a sample then is the smaller group of observations that we make or data that we collect because we usually can't measure everyone. So for example, I might say, okay, the students in this class are graduate students, and so why don't we figure out the ages of the students in this class and see if that gives us a sense of the ages of the graduate students at the University of South Dakota. And so that would be a sample. I would be drawing a sample of ages by asking you all how old you are, which I won't do, I promise. Next slide, slide 8. Okay, here's another couple of terms that are going to be very important. Descriptive versus inferential statistics. Now, descriptive statistics tell us about a set of data. So for example, in this class, what is the average age? In this class, how variable are students' ages? Or what's the range of students' ages? Now, making inferences is when you want to go from a description about a sample and infer it to some larger population, or you want to relate one thing to another. So, are students at USD younger than are graduate students at USD younger than other graduate students around the country, or younger than average? Are graduate students in health sciences programs younger than students in education programs? So I might take a sample of I might ask a sample of graduate students in health sciences programs how old they are. Take a sample of students in education programs and ask them how old they are, and compare the average ages of those two samples. And then, so I'd be making a comparison and trying to infer to a population, oh, that those in education graduate programs tend to be older than those who are in graduate programs in health sciences, or whatever my conclusion is going to be. I'm not really going to want to so much talk about those people that I actually asked, but I want to make generalizations or inferences to a larger population. Next slide, slide 9. So to bring this all together, statistics are numbers we use to describe our sample. But there's another term, parameters, are numbers that we use to describe a population. So I would have the average age of a sample of students would be a statistic, whereas if I were able to find out the age of every single graduate student at USD, for example, and that was going to be my population, that would be the parameter. I would know that for certain what the age of my population. So at the average age of my population. So statistics are used to let us make inference about parameters. Usually we can't measure parameters directly, right? So it's not practical to go around to every single class to reach out to every single person. Now, maybe they have that information in the registrar's office. I don't know. But usually we can't measure an entire population directly because usually we want to talk about large groups. We want to talk about all second graders. We want to talk about high school juniors. We want to talk about college freshmen. We want to talk about large groups that we're not necessarily going to go and get data from each person or about each person. And so we get a sample and we use that statistic to make an inference about the population, to make an inference about the parameter in the population. Okay, next slide. Slide 10. So making predictions about populations, first of all, we almost never make perfect predictions. We'd have to know every single piece of data. We often do better if we sample more people. So if I wanted to know about the ages of graduate students here at USD, it would probably be better if I sampled more than just one class. And we can make the best inferences about the population if we sample randomly. That is, everyone has an equal chance of inclusion. So you can imagine that if I'm only sampling from a specific class, there may be certain aspects about that class that make it different from graduate students in other classes. For example, if there are some people who put off taking EDR 762 or Foundations of Statistics to the end, to right before they graduated, then the ages of the individuals in this class might be older than the ages of individual graduate students in other classes. On the other hand, if this tends to be a class that people take early in their graduate career, then the average age in this class might be younger than the average age of the population of graduate students overall. So if we were to randomly ask graduate students across the university how old they are, we would probably be able to make a better inference about the average age of all of the students here at the graduate students here at the University of South Dakota. Next slide. Okay. With each set of slides, I'll have an appendix, and there'll be additional information that you can use to further your knowledge, or it will be things that maybe slightly relate to the content of the session, but we may be coming back to later. So you can peruse it and see if it's something that you're interested in. Okay, see you next time. Bye-bye.